Welcome to section 1.2, graphing linear equations. So we're going to be working with linear equations in two variables, and most of the time the variables we use are x and y, where x is our independent variable and y is our dependent variable. And the very first form we're going to look at is something called the standard form of a line, and it looks like this. Looks like ax plus by equals c. And this is, again, a linear equation in two variables. Two variables, we see that our variables right here are x and y. So that's the two variable part. And the linear part is because that the exponents on our variables x and y, it's the invisible exponent, which is 1. All right, so there you go. So again, this is called a standard form of the line, and what we do at this point is, or what we're going to do in this section, we're going to find solutions to our line, and solutions are values of x and y that make the equation true. Okay, so an example of that would be down here, 3x plus 5y equals 15. So in this case, uppercase A, B, and C are now our numbers. So again, this is an example of a standard form of a line. So we've said it before, but what we're going to do is we're going to find solutions, values of x and y that satisfy our equations, and that means it makes the equation true. So an example of this is we can just make up a value for x. We can make up the value 10, plug it in, and then find what y has to be if x is 10. So let's see what that looks like with our example 3x plus 5y equals 15. All right, so again, we're saying x is 10. So wherever we see an x, we're going to substitute 10. All right, so 3 times 10, 3x is really 3 times x. All right, so we have this. So now we have a linear equation, and we're going to solve it for y. And this is going to tell us what y has to be when x is 10. All right, so we're going back to some elementary algebra. We isolate y to solve for y. Anything that isn't a y, we move to the other side. 30 minus 30 is 0. And so we have 5y is equal to 15 minus 30. And then final step to isolating is we divide out by the coefficient. Always your last step. And then we get y is equal to negative 3. All right. And we can do a quick check. We can plug in x equals 10 and y equals negative 3 to our original equation, and it should be a true statement. All right, so 3 times 10 is 30. 5 times negative 3 is negative 15. And indeed, it does equal positive 15. So we know we found this correctly. So this is a solution. X equals 10 and y equals negative 3 is a solution. A shorthand way of writing that is as an ordered pair, x and y. And again, in this case, x is 10 and y was negative 3. So this is a solution. And again, we write it as an ordered pair. So if you forgot that vocabulary term, let's write it really quick. We write this as an ordered pair solution. Okay. And ordered pair solution x and y, if we had different variables, like let's say s and t, you organize your ordered pair just alphabetically. So 10, negative 3. And notice we just plugged in x equals 10, we chose that. But technically there's infinitely many numbers we can choose for x. We can choose 0, we can choose 1, negative 20, we can choose 1/2. Infinitely many values of x we can choose, and then we would solve for y. So that means there's actually infinitely many solutions to a linear equation in two variables, and that's this next part right here. Infinitely many solutions to our linear equation in two variables. And so we have the equation that kind of tells us this relationship, but we can also organize all of our ordered pair solution set on our coordinate system. And that's what we call graphing, right? That's what we call graphing. Okay, so that's the direction we're going. We're going to be graphing on a coordinate system the solution sets to all of these linear equations. Let's remind ourselves of some things. This is our coordinate system. It's made up of quadrants. You count the quadrants counterclockwise. So 1, 2, using our Roman numerals, 3 and 4. Our ordered pair x and y, we have our x-axis is the horizontal, and then we have the y-axis is our vertical axis. And then where they meet, they're both number lines. If you look at them individually, they're both number lines. And they meet at the zeros. And we call this ordered pair 0, 0. It's also called the origin. Okay. So let's go back to our example, 3x plus 5y equals 15. And we're going to organize the solution set on our coordinate system. That's a fancy way of saying graph. Okay, so what we're going to do, we're going to plug in some ordered pairs. Let's use a table. So we have our x values and our y values. I like to organize them like this. Let's plug in... Let's plug in 5 for x and see what happens. So if x is equal to 5, we can do a little scratch work down here. X is 5, so 3 times 5 plus 5y equals 15. That's 15 plus 5y equals 15. Subtract the 15s. Ooh, we get 5y equals 0 after we subtract 15. So 5 times what is 0? 5 times 0 is 0. So we have our first ordered pair 5, 0. That's our first ordered pair solution set. So this spot right here in red is when x is equal to 5 on our horizontal axis and y is equal to 0. Okay. We can also plug in values for y. For instance, we can plug in y is equal to 3. Let's do a little scratch work. So if y is equal to 3, we have a similar situation. All right, I did this on purpose. I knew I was going to get x and y to be 0. All right, so you subtract the 15, 3x. After we subtract 15 from both sides equals 0. 3 times what is 0? 3 times 0 is 0. So that tells us x is 0 in this case. So we have our new ordered pair 0, 3. So x equals 0 is, we're not moving left or right, but y is 3, so we're going to go up 3. So there's your other point. Okay, and if we were to plot more points, we would see that this ends up being a line, which is why they're called linear equations, because the graph of the equation is a line. All right, and 2 points make a line, so we're good to go. Okay, so again, if we were to find or calculate any point along this line, so these all represent ordered pairs, if we plug in the corresponding x and y values, it's going to make 3x plus 5y equals 15 a true statement. And on that note, if we find anything that's not on the line, so for instance, the ordered pair 4, 4, 4, 4 is not a solution to 3x plus 5y equals 15 because it's not on the line. All right, so in the yellow and on the line, these are solutions because that's what a graph is. If the point is not on the line, it's not a solution. All right, let's look at a different example. We're going to be graphing. Notice this one is a little bit jumbled. So we're going to have to unjumble it. So we are going to graph negative 3 times y minus 5 is equal to 2 times 3x minus 6. Okay, so we can do this a couple different ways. We can just start plugging in values of x and solving for y. Definitely. That looks a little bit messy to me. So I'm going to first clean up our equation. I'm going to do it by solving for y. So first things first, we get rid of our parentheses. So let's distribute the negative 3. So negative 3y, and then negative 3 times negative 5 is positive 15. All right, so we distributed the negative 3. And then on the other side, we're going to distribute the 2. Lovely. All right, and I'm going to solve for y. I'm going to solve for y right here. So anything that's not a y is going to go on the other side. So to move the positive 15, I'm going to subtract 15. And then again, I want to isolate this y, so now I can divide out by that coefficient. Make sure it's negative 3, not just positive 3. Whatever I do to one term, I have to do to all when we're dividing or multiplying. Negative 3 divided by negative 3 is 1, so that cancels. 6 divided by negative 3 is negative 2. Negative 27 divided by negative 3 is positive 9. All right, and then for now, we're just going to be doing our point plot method. So let's do a teeny tiny XY table. Hopefully you have more room than I do. And because y is already solved for, y equals negative 2x plus 9, I'm just going to plug in our x values. And I'll just do maybe negative 1, 0, and 1. All right, so we plug in negative 1. We're looking at, remember to do multiplication first. So this is going to be positive 2 plus 9 is 11. And there's our first ordered pair, negative 1, 11. Let's plug in the 0. All right, so order of operations, we do multiplication first. That goes to 0 plus 9 is just 9 itself. That's our next ordered pair, 0, 9. All right, and then finally we plug in the 1. Negative 2 times 1 is negative 2. Plus 9 is 7. All right, so let's graph this. I'll just graph this on the side right here. So it's going to be a taller graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is the highest point. So that's where I'm going to start. All right, remember to label your tick marks. That tells us the scale we're looking at. So each tick mark is equal to 1. Our first ordered pair has x equals -1 and y equals +11. Next one is x equals 0, y equals 9, x equals 1 finally, and y equals 7. All right, and those three are lined up. And now we just connect our dots. All right, so there's the graph of that more complicated one. Let's look at another example, graphing. So graph y equals -1/2 x. And again, let's just do our point plot method. Y is already solved for, y equals something. So I'm just going to plug in values for x, and it is going to chug out y. Notice this time if I were to plug in like a -1, I'm going to end up with a fraction, -1/2. And if I plug in a +1, I still have a fraction. Or excuse me, +1/2. And I plug in 1, I get -1/2. And it's kind of hard to plot points that are fractions. So let's plug in values of x that are going to cancel with that denominator of 2. So for instance, instead of -1, 0, 1, strategically, to cancel that denominator, let's just do even numbers. All right, and if our denominator, if it was like -1/3 x, if our denominator was 3, we would put in multiples of 3 to cancel our denominator. Okay, so when we plug in a -2 now, it cancels with our denominator. And then -1 times -1 essentially is +1. So there you go. When we plug in a 0, 0 times anything is 0. And then finally plug in our 2. If it's helpful, remember you can always write 2 as a fraction, so you know what to cancel. Sorry, that's an equal sign, equals -1. All right, and then we can graph those ordered pairs. Our first ordered pair is -2, +1, then 0, 0, and then 2, -1. And then we connect our dots, and there's our line. Okay, let's continue on. We're going to be talking about intercepts next, and we're going to be graphing using intercepts. Sometimes it's a fast way to graph. It's a strategy. So to remind ourselves about our intercepts, let's just kind of do a generic graph. There's our x, y, and then let's say, this is our line. Hopefully yours is a little bit straighter than mine. Our intercepts are where the graph touches the axis, or axes. In this case, we have 2. All right, so this is our x-axis. So this is considered our x-intercept. X-intercept is on the x-axis. And a point is on the x-axis, essentially, if we don't go up or down. So this means our y value has to be 0. So all x-intercepts have 0 for their y value. All x-intercepts have 0 for their y value. And then traditionally we call it just a. All right, so whatever a can be. All right, and then over yonder, our other intercept is going through the y-axis. So the second intercept is called our y-intercept since it's on the y-axis. And notice to be on our y-axis, we can't move left or right. We're at 0 for x. So all y-intercepts are going to have 0 for their x coordinate. And traditionally we use the letter b. All right, and that's your y-intercept. So to summarize, to find the y-intercept, let x be 0. And solve for y. And then to find the x-intercept, let y be 0, and then solve for x. All right, so let's practice. We're going to graph 2x minus 3y equals 12 using intercepts. All right, so one way to do that is when we're making our xy table, is just to know we're going to be doing this. All right, so again, when we figure out this y value, this is going to be our y-intercept. When we figure out this value, this is going to be our x-intercept. All right, and I like using intercepts because zeros make these guys just disappear. For instance, if we were to plug in x equals 0, this 2x disappears because 2 times 0 is 0. And we're just left with negative 3y equals 12. We can almost do that in our head. Negative 3 times what is positive 12? Negative 3 times negative 4 is 12. So when x is 0, y has to be negative 4. In similar situation, to find our x-intercept, we let y equal 0. And again, it kind of just makes this whole term disappear. And we would be left with 2x minus 12. 2x times what is 12? 2 times 6 is 12. All right, so we can do minimal work, sometimes, of course, when graphing using intercepts. So let's finish this problem up. By graphing 1, 2, 3, 4, 5, 6 is going to be our x-intercept. 1, 2, 3, negative 4 is our y-intercept. All right, so x equals 0, y equals negative 4, x equals 6, y equals 0, and then we have our nice line. Okay. Something else we can do with our intercepts. Is we can find it using just this generic formula. So in example 4, we want to find the x and y intercepts for essentially a formula, right? This is a formula. There's no numbers in it. It's a formula in A, B, C, and the variables are x and y. So if we wanted to find the x-intercept, for instance, we would have to let y be 0. So to find the x-intercept, we're going to let y be 0. I'll do that in red. And we're going to solve for x. All right, let's get rid of parentheses first. And remember, we're solving for x, so anything without an x is on one side. Anything with an x is on the other side. So now all that's left to do is divide out by AB, and we get our x-intercept. So our x-intercept is C over AB, and you can write that as an ordered pair. Okay, and similar situation for our y-intercept. If we wanted to find our y-intercept, now we let x be 0 and solve for y. Okay, so again, in this case, I let x be 0. That whole term b times 0 is just 0, so that's going to go away, and we're left with ay. A times y, remember that's what that means, a times y. And we're solving for y, so again, divide by a, and we have our y-intercept. And again, you can write that as an ordered pair. When x is 0, y is c over a. Okay. So next, we are going to be talking about our vertical and horizontal lines. And we're going to think of formulas for both of those. So let's do this kind of intuitively. Let's draw a vertical line. and we'll make it through a point. Let's just say this is x equals 3. And we have a vertical line. All right, and then let's examine some of the ordered pairs. The x-intercept is going to be 3, 0. And notice when we're doing a vertical line, we're not moving to the left or the right. We're just staying hovering over x equals 3. So maybe up here, x is 3 and now y is 4. Maybe right here, x is still 3, but now y is 2. Down here, maybe x is 3, y is -1, something like that. But moral of the story is that the x is the same. X is always 3. And the y values are allowed to change. So this is actually the equation of a vertical line because we don't go back and forth. We don't go left or right. So the x value is always 3. So x value is a constant for vertical lines, all vertical lines. So in the equation of the line, we just have one variable. It's just the variable x. And in general, it could be, if we wanted to write a formula, it could be x equals a, where a is some number. So x equals 3, x equals -2, x equals 1/2, something like that. All right, and then similar situation is our horizontal lines. All right, so let's say we have this horizontal line. Let's call this 2. So again, when we're constructing a horizontal line through 2, notice all the points, we're not moving up and down. All the points are staying steady at 2. We're not allowed to go up and down. So if we wanted to examine some ordered pairs here, for instance, this ordered pair, we're a little bit farther out. Maybe that's like x equals 3, but y is still 2. Right here, this looks like maybe x is equal to 1 now, but the height is still the same. The height is still the same. It doesn't change. So in this case, this equation of the line, y is always going to be equal to 2. And for horizontal lines, y is a constant, and x can do whatever it wants. So again, for our horizontal line, we're just going to see one variable. And the generic way of writing it as a formula is y equals b, where b is a number, like y equals 2, or y equals 1/2, or y equals 1,000, something like that.